This is problem number 35 in section 1.3, and it has to do with using algebra to find the real solutions of an equation. So the real solutions means what are the values of x that are going to make y equal to 0. So that the real solutions has several different ways you can describe it. You can describe it as the solutions. You can describe it as the zeros. You can call it the x-intercepts. Sometimes it's called the roots. And sometimes we call it factors. But what they are, they're the values for x that are going to make y equal to 0. So if I was to graph it, they're the values for x that are going to be making y equal to 0, so anywhere on the x-axis. So anytime I would cross the x-axis, that would be a 0, a solution, a root, or an x-intercept. So we need to find those. Well, if I had kind of a simple equation, let's say like x minus 2 times x minus 1 equals 0, and I said find me the zeros, what are the values of x that will make y equal to 0? Well, you can see pretty clearly it would be 2 and it would be 1. You try and factor it out so you can find out what are the values of x that are going to be, that will make the answer 0. And if I was to graph just this little tiny equation right there, which I'm going to do right now by putting it into the calculator that I just made magically appear. So I have x minus 2 times x minus 1. I'm going to graph it. Let's kind of zoom in on it a little bit. I'll go my window, and I'll make it negative 4 and 4. And again, I'll do negative 4 and 4, so I'm kind of zooming in on it a little bit. I'll graph it. And it doesn't like that. Why not? My window. Oh, let's see. Negative 4 and 4. Negative 4 and 4. I think it'll graph it now. There we go. And I can see that my solutions, my x-intercepts, my roots are right there at, just as we expected, 1 and 2. But before I can get to that point on this equation, I have to do some algebra. I have to make it more simple to work with. So I'm going to start, and there's a variety of ways to start on this type of a problem, but I know eventually I'm going to need to get rid of all these denominators so that I can have x just all by itself. So what I'm going to do is I'm going to start by multiplying both sides of this equation by 5. I want to get rid of this denominator right here first. This one right here. I'm pointing to it. You can't see me pointing. So I'm going to take my 5, which is the same thing as 5 over 1, and I'm going to distribute that to both terms in this expression right here. So I'm now going to have 10 over x plus 2 plus 15 over x minus 1 is equal to, my 5's cancel out, negative 8. Now I have to worry about these denominators here. They're a little bit more complex. They have a variable in them, but I need to get rid of them. So you know what I'm going to do is I think I'm going to do it, well, here's what I'm going to do. I'm going to multiply both sides of this equation by both of these denominators. So I'm going to multiply this. Let's see if I can put this over here. I think I can. There we go. Yeah, I can do that. I'm going to multiply my left side by x plus 2, x minus 1, and my right side by x plus 2, x minus 1. Because I know if I multiply by all of my denominators, all of my denominators are going to go away. So in doing this first term here, x plus 2 times x minus 1 times 10 over x plus 2, well, my x plus 2 is going to cancel out. So it's just going to be 10 times x minus 1, which is 10x minus 10. And now when I take these both and I multiply them times this term, it's going to be my x1 that cancels out. So all I'm going to be doing is multiplying my x2 times 15, which is going to be plus 15x plus 30. And that is equal to negative 8 times x plus 2, x minus 1. And I think we can simplify the left side a little bit and the right side a little bit. So I'm going to combine my like terms. I have 10x and 15x, so that makes 25x. And I have negative 10 and positive 30, that makes plus 20. And that is equal to, I'm going to go negative 8 times, and I'm going to FOIL this out. If you remember FOIL, first, outer, inner, last. I'm going to do that multiplication. So that's going to be 8 times, and I'm going to look at this, it's going to be x squared, or negative 8 times x squared, and then my outer is minus x, and my inner is plus 2x, and my last is negative 2. Well, let's do a little more simplification. 25x plus 20 equals negative 8 times x squared plus x, so combine these two terms, minus 2. Keep going. I'm going to have 25x plus 20 minus is equal to negative 8x squared minus 8x plus 16. Now, if you remember in that easy quadratic that I did just a minute ago, it was x minus 2, x minus 1 equals 0. And when we want to solve a quadratic equation, we want to get all of our terms on the left-hand side and make it equal to 0. Because that way we can either factor it or we can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You solve the quadratic equation and it gives you the roots or the zeros, whatever you want to call it, or the solutions for x that will make it equal to 0. X-intercept that will make y equal to 0. Well, we have a quadratic equation right here, but we want to get it in standard form. Everything on one side equal to 0. So what I'm going to do is I'm going to subtract 8x squared from both sides. I'm going to add 8x squared to both sides, because then I'm going to have a positive 8x squared, and I really much prefer to deal with positive coefficients than negative coefficients. So I have 8x squared, and I can add 8x to both sides as well. So that's going to give me 25 plus 8, 33x. And I think I will subtract 16 from both sides. So 20 minus 16 is plus 4. And now I've gotten rid of all of these terms, and that is equal to 0. So that is a happy quadratic equation because I've got it equal to 0 now. So trying to solve for x here, I could use the quadratic formula, but I'm looking at it and I'm thinking, you know, I think this thing can be factored, and I'm going to find out if it can be. And so I'm going to use the Surefire factoring method, sometimes called the Mr. LeBron method. And there is a little video that I emailed out to everybody, or that's on the video index, about how to do the Surefire method. Well, I'm going to do it now. What you do is you take the coefficient of the first term and multiply it by the last term. So the coefficient of my x squared term times my constant, and that equals 32, positive 32. And I want to know if there are any factors of positive 32 that when added together will give me my middle term of 33. And I can see really clearly that there is. 32 and 1 are factors of 32. And when I add them together, I get 33. So I'm pretty happy about that. And what I do then is I keep my 8x squared, but I change my middle term. And I change it from 33x into plus 32x plus, I'll write 1x, so that we have the 1 there. Now I still have my 4, plus 4, now that equals 0. Well, when you do this with the Surefire method, and it's Surefire because if you can find factors of that product that equal the middle term, you're going to be able to factor this. If there are no factors of this middle term, of this product here, if there are no factors of that product that equal the middle term, then it is unfactorable, and you have to go to the quadratic formula. But I found some that are, so now I know that I'm going to be able to factor this, and here's how I'm going to do it. I'm going to group these two terms, leave the plus, and I have 1x plus 4. Well, I'm going to take this term right here, and I'm going to factor out 8x. Well, okay, that leaves me with x plus 4. That looks pretty good because that's what I have right over here. So 8x times x plus 4 plus, let's call this 1 times x plus 4. Really didn't need this one right here, but it's there. Well, I can pull my x plus 4 out of both of these terms here and end up with x plus 4 times 8x plus 1. That's pretty nifty. And just as a little aside here, I want to make sure that this is really clear how I pulled that x plus 4 out of this. It's as if I had a times b. Do I want to do it that way? I'm not sure. Yeah, I think so. A times b plus c times b. Here, this x plus 4 is the same in both sides of this sum right here. Here, the b is the same on both sides of this sum. And I think with this one here, you can see pretty clearly, I can pull the b out, and it leaves me with times a plus c. Well, in this case over here, my b happened to be x plus 4. I pulled out the x plus 4, and it left me with the a plus c. I hope that was helpful and not more confusing. So I know, this is now my little sidebar, and I know that this is equal to 0. So now I can see pretty clearly that my solution is either x plus 4 is equal to 0, or 8x plus 1 is equal to 0. If I get either x plus 4 equal to 0, the whole product will be 0, or if I get 8x plus 1 equal to 0, the whole product will be 0. So I'm going to subtract 4 from this, and I get x is equal to negative 4. That's one of my answers. And over here, I'm going to get, I'll subtract 1 from both sides. I'll get 8x is equal to negative 1. I think I'll divide by 8 on both sides. And I get x is equal to negative 1/8. So algebraically, these are my two roots. Now, as the last part of this problem, I am going to put it into the calculator and test my results. And I'm gonna let you watch me plug this into the calculator. So I have one term that is 2 divided by parentheses x plus 2 plus 3 divided by x minus 1. That is that is one side of my equation, and if I graph that, it looks like this. Kind of a strange looking graph, but what I know about graphs, that looks pretty reasonable. My other equation, my other side of the equation, is negative 8 divided by 5. So I'm going to enter in another equation there, and I'm going to go negative 8 divided by 5. Y equals negative 8 divided by 5. And I'm just going to graph just that one, so you can see what that looks like. That looks like that, just a straight line at negative 8/5. So if I put both of these graphs together, the intersection of the points on both of these graphs is going to be where they are equal. So I need to find the intersection of the two graphs. So I can see that one of those points is going to be right about there, and another point is going to be right about there. But right about isn't close enough, I think, in this case, especially since we factored it. Let's see if we can find out whether they're exact. So I'm going to go second, calc, and I'm going to look for the intersection of those two graphs. So I push 5, and it's asking me my first curve, which is my y1 right here, and I think that's okay. So I go, that's okay. I said, that's okay. All right, doesn't like me to, not letting me do that. My second curve, it's on y2 equals negative 8/5, and that's okay. I don't want to make a guess right now, but I'm going to press enter. And it gives me, yes, one of my intersection points is right here. X equals negative 0.125. X equals negative 0.125, which you will find if you do a little bit of the math right there. It's the same thing as negative 1/8. Negative 1/8, you divide 8 into negative 1, you're going to get negative 0.125. So that's one intersection. I'm pretty happy with that. I want to find the other one, which is over here someplace. So I'm going to do the same thing. I'm going to go second, calc. I'm going to find the intersection. My first curve is fine. My second curve is fine because I only have two curves. But I am going to make a guess here, because if I don't make a guess, I think it's just going to give me the same negative 0.125. So I'm going to guess a little bit to the left. I'm going to guess like negative 3 and see what it gives me. And I'll push enter. And sure enough, I found the intersection closer to negative 3. which is right there at our other answer, -4. So we have now solved this problem algebraically. We've used our calculator to verify our results, and boy, that was a lot of talking to solve this problem, don't you think?